Okay, this is our next video talking about finding circular trigonometric functions of certain special angles. And remember, once again, you need to memorize these definitions for trigonometric functions. And notice that if we know x, y, and r of any point on the terminal ray, we can use these definitions to find the trig functions where they are defined. Now, if you remember last time, our last video, we took a special triangle here, this one that's an isosceles right triangle, and it was natural to put it in a circle of radius square root of 2, and that allowed us to find trig ratios of all the angles that were had a reference angle of pi over 4, or 45 degrees. In this video, we're going to look at the other special triangle here. We found this, if you remember, by taking, the way we found this was by taking an equilateral triangle, cutting it in half, and what was left had a 30, 60, and 90 degree, 30 degrees, 60, 90 degrees, or pi over 6, pi over 3, and pi over 2, and it turns out that the sides are, if one is x, the longer side, the shorter side is x, the longer leg is square root of 3 times x, and the hypotenuse is 2x. So specifically, we can look at one right here. And so going back to where we were here, we're looking at this triangle. Okay, now once again, we want to take this triangle and let's see, I think this is, yeah, the pi over 6 is up there. There we go. That's better. So the pi over 6, or 30 degrees, is the smaller of the two angles opposite the side 1, and the pi over 3, or 60 degrees, is opposite the side of length square root of 3. And we want to take the whole thing and place it right here at the origin. So notice that naturally is going to lead us to look at a circle of radius 2 for these. And notice our reference angle is 60 degrees, or pi over 3 radians. So what we want to look at in this video is, what about finding trig functions, exact values, of angles whose reference angle is pi over 3 radians, or 60 degrees. So we'll be placing this triangle at the origin, maybe turned around different ways, like we did the last example. Okay, so let me move this up just a little bit so we can see the whole circle. Okay, so what we're doing is this one here, and these are the angles where we have a reference angle of 60 degrees, or pi over 3 radians. And so the circle x squared plus y squared equals 2 squared, x squared plus y squared equals 4, in other words, is the circle of radius 2 that you see in blue here. And so if we want to illustrate that, this is what we're looking at. So let me notice those are lined up so they have the same y. And then they're lined up the other way so they have the same x. So there's a lot of symmetry going on here. But let me, just so that you don't get confused here, let's let those dotted lines are not part of our reference triangles. Now, square root of 3 is the length of these vertical pieces, and the 1 is the length of the horizontal pieces, and 2 is the length of the hypotenuse of each one of these, or the radius of that circle. And so you can see there. So what angles are we talking about? Well, if we're talking about rotating around, let's see if I can do this here. And to where we have something in the first quadrant here, that's 60 degrees, or pi over 3 radians. Of course, we could also get it by 1. That's 60, there's another 60, and another 60. In other words, this is pi to here. We break it into thirds. This is 1/3 pi, 2/3 pi, and pi. So 1/3 pi, 2/3, 3/3, 4/3, 5/3, 6/3. So this would be pi over 3, or going this way, 1, 2, 3, 4, 5 pi over 3 negative. So negative 5 pi over 3, or again we can rotate as many times as we want. What matters is what happens when we end there. So what are the coordinates of that point labeled P right at the moment? Well, x is 1, y is the square root of 3, and r is 2. And we know that from basically putting this is our special triangle that we're putting right there. Okay? And so we know that is going to be the case. Well, what are the trig values then? Well, of course, anytime we have x, y, and r, pretty simple to use our definitions to come up with the trig functions. So cosine of the angle is x over r, so that's 1 over 2. Sine is y over r, so that's square root of 3 over 2. And tangent is y over x, square root of 3 over 1 is just square root of 3. Secant is r over x, that's 2 over 1, which is 2. Cosecant is r over y, so that's 2 over square root of 3. And cotangent is x over y, that's 1 over square root of 3. So, again, rather than trying to memorize all this stuff here, okay, or even all this stuff, just think about taking that special triangle, okay, that we have and placing it right there. And we know the ratio of the sides are 1, 2, and square root of 3. So if we use a circle of radius 2, that will work out nicely. Okay, what if we rotate a bit more and we rotate now not just pi over 3, but 1, 2 times the pi over 3. Notice that we're just another pi over 3 away from horizontal, so this reference angle right here is still pi over 3, or 60 degrees. So it's 60 degrees from the horizontal, but it's 120 degrees from the original initial side here. So this would be 120 degrees, or 2 pi over 3 radians. Okay? And what do we see there for the x and y of that point? Well, x is going to be negative 1, y is square root of 3, and r is 2. Again, notice that's the same congruent reference triangle. It's just reflected over the y-axis from what we had a while ago. Remember, 1 is the shorter side, so the shorter angle is at the top, so that means the shorter side here. So the length of this side is 1, the x value. I've got this labeled not with its length, but with its actual x coordinates for these 2 points over here. So now we can just do, we know x is negative 1, y is square root of 3, r is 2. Use our definitions to come up with here for the trig functions. Cosine again is x over r, negative 1 over 2. Secant's the reciprocal of that, 2 over negative 1 is negative 2. Sine is y over r, so that's square root of 3 over 2. Cosecant's its reciprocal, 2 over square root of 3. Tangent is y over x, that's square root of 3 over negative 1 is negative square root of 3, and cotangent's its reciprocal. In a similar manner, if we rotate in the negative direction by pi over 3, we're down here in the quadrant 4 down here, and we see that that's negative pi over 3, or negative 60 degrees, or perhaps if we rotate in the positive direction, what would we get? Well, we get 1, 2, 3, 4, 5 pi over 3, or 300 degrees, 60 degrees short of a full rotation, or pi over 3 short of a full 2 pi rotation. And we get x is 1, y is negative square root of 3, r is 2. Remember, r is always positive. And use our definitions here, x over r for cosine, which is 1/2. Secant is positive. Sine is y over r, so negative square root of 3 over 2. Cosecant's its reciprocal. Tangent is y over x, that's negative square root of 3 over 1. And cotangent's its reciprocal. Similarly, if we rotate from horizontal negative 2 pi over 3, or positive negative 1, 2 pi over 3, or positive 1, 2, 3, 4 pi over 3. Okay, that puts us over here at 4 pi over 3. That would be 240 degrees, or negative 2 pi over 3, negative 120 degrees. Those are the two shortest rotations, one in positive direction, one in the negative, but there are of course many other ways you could spin it and still land here. Either way, when you land at that point, P has coordinates negative 1, negative square root of 3, and 2, and you can get these to work out. Notice that all of these have the same size of the cosine. The cosine is either 1/2 or negative 1/2. It is 1/2 when you're over here in the first or fourth quadrant. When x is positive, it's negative 1/2 over here and here, because these have the same, they all have the same r of 2, and the x is the same. We got a lot of symmetry going on here, so the x is the same both ways, same absolute values, either 1 or negative 1. Similarly, the y's up here are 1 here and here, okay, and so we get y's are square root of 3 up here and here. They're both positive, okay, and so what that tells us is that these are going to have the same sign, which is just square root of 3 over 2, and these are going to be the opposite because they're reflected over the axis, so they have the same absolute value for the y, but opposite sign. And so a lot of things going on with the symmetry of the circle that we can see there. So those are the ones with that we'll do that have a reference of pi over 3 radians or 60 degrees.